So macroscopically, you might not think there are crystals, but if you look down here, you can see there's lots of little tiny crystals in here, dark ones and light ones. And you can see there's these huge gaps as well, these huge holes around the place. So that'll be interesting to do the water test, see if water will go into the holes or not. So I'll try and just put a whole heap of water in there, and it doesn't go through. It's not really porous. They're just gas bubbles. So you can see quite well that the water doesn't do anything. So it's not going in. It's kind of cool. So it's obviously pumice, but we're still going to use the charts because it's one of those well-known ones. And this one's just famous for floating. So here we go. It's a beaker. Goodbye to the... And we just pop it in there and it floats. All right, so if I don't have a nice little light on it. There you go. It floats. What was I saying? So I could say that's amorphous and then go the fairly hard, vague crystals, igneous. Or I could see that there are a few small crystals and then just go down the granite route or basalt route, really. Dark or hard, random crystals, quartz felt, but probably fits better to go down the extrusive igneous. All right. And that makes sense because it comes out so fast. It's still got gas bubbles and stuff in there. So let's go down to the igneous rocks. And so it's very close to obsidian. It is a very glassy look. It's non-crystalline. The only difference is it's vesicular. It's got gas pockets. So it's pumice because it's a light color continent. If it's a darker color, then we'd call it scoria. Looks very similar, it's just darker color, and this is sort of a whitish cream color. And so that's easy, it's pumice.